Remember areas of polygons and circles. So please, one of the things that I find that you guys come in here for some reason, you're confused about the difference between perimeter and area. Okay? Perimeter is what, everybody? The distance around. Add up all the sides of the figure, right? And what's area? It's the number of square units within it, right? It's always in square inches, square centimeters, right? Perimeter is always a linear unit, okay? Always a linear unit. So, for example, we have a square. All the sides are congruent, are they not? So if we call them all S plus S plus S is 4S, right? A rectangle, it's got a length and a width. So generally, it's not too horribly important. Well, what do you call length and width? Usually the width is the narrower measurement, but it really doesn't make any difference, right? So that's length, that's width. This would also be length and width, right? So L plus W plus W is 2L plus 2W if you want to simplify it. Triangle perimeter, are you kidding me? Okay? And then a pentagon, call them all S. The perimeter is 5 of those S's, okay? And you add them up. Now, when we go to a circle, we don't really call it a perimeter because it's not a polygon, right? You can't add up sides in a circle. How many sides does a circle have? Well, sort of. Yeah. How about an infinite number of sides? Like, could you not approximate a circle starting out with maybe a square? Not very close to a circle, is it? Well, let's add a side and call it a pentagon. Get a little closer, isn't it? Add a side, call it an octagon. Or 10 sides, decagon. Are we getting closer to a circle by adding sides? And maybe you got a 20gon, right? I'm not sure the name for that, so it's called a 20gon. Huh? What is it? No, a decahedron is based on 10, and that's a three-dimensional figure. Sure, you got 100 sides, right? You're starting to get all those sides smaller and smaller. You're approaching a circle, okay? So you can almost think of a circle as having infinite sides. Well, you can't add infinite things, can you? Right? Okay? You don't have time in the universe to do that. Okay? So we have a little formula for circle. There she is. Hang on, come here. Wait, come here. It's from who?
Alo.
Who?
Mr. Alo.
Oh, Mr. Alo. I know him. So circumference is like perimeter. It's analogous to perimeter, but not exact. It's the distance around a circle. So before we get to the formula for the distance around a circle or circumference, we need to talk about how the circumference of a circle relates to a diameter. Okay? So the perimeter of a circle is called a circumference. Should do that in blue. Right? And any particular section of a circle, right, is called an arc. And all the way around the circle would be the full arc, 360 degrees, right? So we have the circumference is basically the full arc length of a circle, right? So let's look at the relationship between diameter and circumference, okay? And you've heard of the number pi, haven't you? It's up there on my wall that Mrs. Altieri put up there years ago when she had this room. She apparently had a lot of time on her hands because I don't know how many decimals that is. She has it out to. It's like probably a couple of hundred decimals, right? But you know what goes on in it, right? Everybody know where pi comes from? Did somebody just make that number up?
Yeah.
No, they did not. It comes from a very specific relationship. Right? Take a look at this this little circle here. Okay? Here's the diameter of that circle. Now here's a line segment. We're going to take the length of this diameter and place it here. And then add another one to the end of it, and add another one to the end of it. How many oh, and by the way, sorry, this line segment represents the circumference of that circle, like unrolled, okay? That segment is the exact length of the circle circumference. And notice there are 1, 2, 3 diameters that fit in there. Do 3 of them fit in exactly? No, it's a little bit more at the end there, right? Could be, yeah. Let's look at a bigger circle. Here's a bigger circle, right? Here is its circumference unrolled, okay, from here to here. Here's its diameter length. How many fit on that length? 3, right? So we've got 3 of them. That's doing that. 3 diameters, plus just a little bit more here. Would you say this little bit more might be? 0.14. Does that look familiar? 3.14 dot dot dot. What number do you think that is? Pi. Okay? So pi actually comes from someplace specific, right? It's not just made up. So you guys, you would all agree that all circles are similar, yeah? Right? Which means if they're all similar, all their corresponding parts are in proportion, which means they have the same, there we go, ratio. Pi is a ratio. What do you think the ratio is that gives you pi based on what we just said? Ratio of something divided by something. And all circles are similar. Based on what we just talked about, what do you think the ratio is that pi comes from in circles? Look how we laid it out. Something divided by something. Give you a minute. I couldn't hear you.
Actually, did speak up.
You got to speak up. Well,
Sorry.
confidence. That's where pi comes from. It's a ratio. Could you think of pi as a scale factor? All circles are similar. So isn't pi kind of like a scale factor for dilation? We make a circle bigger, right? Does the number of diameters that fit on its circumference change? Circumference divided by diameter is always some number, 3.14 whatever, okay? Now, the history of this particular ratio called pi goes back a few thousand years, right? The ancient Greeks first pondered it. Well, they estimated this pi. They didn't call it pi back then. It wasn't called pi until about 1750 something, some other mathematician. But they recognized this as being about 3, okay? And that's about as close as they could come because they didn't have decimals, right? They didn't have really a concept of numbers in between integers, right? But as time went on and more mathematicians looked at this, they started generating, more decimals, okay? More accurate approximations of pi. You know it has an infinite number of decimals, right? Goes on forever and ever, right? So we're never going to get the full number, the full value of pi, okay? So time goes on and mathematicians develop these algorithms. They sit and work on this stuff, and some mathematicians, before the advent of computers and calculators, got pi out to probably 10 decimals and 20 decimals. Then maybe another 100, 150 decimals. I can't remember exactly how it went. And then in the 20th century, it was somewhere around 1944, the first computer was invented, right? As you know, computers can do calculations very, very quickly, much faster than we can, right? And I believe the computer that they used to calculate pi the first time was ENIAC. It was either ENIAC or UNIVAC, back right at the end of World War II. The big thing that took up an entire, room, and all kinds of lights and buttons, and it had less processing power than your watch, okay? Well, they got pi out to probably 1,000 or a couple thousand decimals. So computers got better and better and better over the years, right? And now I think the last one got the pi approximation out to several million decimals. And it went on and on and on. It took several months to calculate this. Some hundreds of millions of decimal places. Well, why? I don't know why. I don't think we'd ever need that kind of accuracy. Even if, our British requirement for accuracy doesn't really need that many decimals, but I guess people are interested, okay? But anyway, so circumference equals pi times diameter, pi d. Well, why is that? Because we just figured out that pi equals circumference divided by diameter, right? Pi equals the circumference of any circle divided by its diameter, okay? I should use a capital, well, I use a capital D, right? If I was to solve this for C, what would I do to both sides? Multiply by D, and you get C equals what? pi times d, right? But how does the diameter relate to the radius? Two of them. So this is probably one you've seen, right? Circumference equals 2 pi times the radius, right? Twice pi d, because the radius is half the diameter, okay? So, and the reason for this is that all circles are what? There we go. All circles are similar, okay? So their corresponding parts are in the same what? Same ratio, which is a proportion, right? So corresponding parts in same ratio. Okay? So pi is a ratio. Like so similar circles come from dilations, right? You can dilate a circle, and then no matter if it's as big as the sun, right? It'll have 3 and some change diameters that'll fit into its circumference. Okay? Think of pi as a scale factor. Ratio of similarity, right? So we're connecting this back to dilations. That's where pi comes from. Okay? Well, let's look at some examples. Simple ones here at first. All right? So, determine the missing information. They give us this equation. C equals 9 pi. We want the radius. Okay? Now, we have two options here. We can either say C equals pi d, which is also equivalent to C equals 2 pi r, right? We go, but let me show you how to set it up this way. If things are equal to other things, can we substitute them? Right? So C, they want radius, right? So C here equals 9 pi, but we also know that C equals 2 pi r. What equation could I set up with substitution? C equals that, and it equals that. So by transitivity, 2 pi r in this case must equal what? Equals 9 pi. Right? Could I easily solve this now for r? What do I do? Divide both sides by what? Well, how about 2 pi? Right? They cancel. What am I left with? And they cancel. So r equals 4.5 centimeters. See how I did that? I didn't substitute pi d because they asked for what? R. So I used the one that they asked for. I mean, they could have put in pi d. They had to divide by 2 at the end, right? Why not use the one directly? So now they give us that the radius is 16. This is simple. The radius is 16. What's the diameter? Double it, 32. Easy. Radius is 3. How do we get the circumference? And they gave us radius. So C, 2 pi, well, 2 pi r. 3. R is 3. Right? What's 2 times 3? So C equals 6 pi. And when you see this E here, that means they want exact. You know what that means, right? Don't put the pi in your calculator and get some decimal estimates, right? Leave it in terms of pi, that's exact, right? That's all. When you leave it as pi, that contains an infinite number of decimals, so it's exact, right? All right, here's the other one. Circumference equals pi. They want us to find the diameter, right? Well, here's something that circumference equals. What else does circumference equal? Pi d. So what can we set up here? If C equals pi and C equals pi d, then pi d equals pi in this case. Right? You get that, right? C equals pi. C also equals pi d. That means that in this case, pi and pi d are the same. They both equal C, so they're equal by transitivity or substitution, right? So then I just divide by pi, don't I? To get d. What's pi divided by pi? 1. So it's got a diameter 1. You follow me? I know some of these are simple enough you can kind of work out in your head, you know how to do it, but I'm trying to set it up as substituting equal things in, because when you get a little more complex, you're going to want to know how to do it that way, right? So let's go to the next page then. All right, you guys take a minute, kind of like what we did on the page before. I want you to set up, use substitution or transitivity, and set up an equality to solve, in this case, for C or for diameter, right? If they want you to solve for diameter, are you going to substitute with pi d or 2 pi r? D, because they want D, right? Okay, so take a minute, work these out, kind of like I did on the previous page, and see how we do. What do we get for number one, guys? 8 pi? Yeah, that's it. R equals 4, they want circumference. Circumference equals 2 pi r, right? So C equals 2 pi, and the r here is 4. 2 times 4 is 8, so 8 pi centimeters, actually, right? That's the exact answer. Did we get number 2 yet? 6.5, right? So C equals 6.5. They want diameter. So we use the fact that C equals also pi d, and do what? If that equals C and that equals C, what can you say about this and that? If they both equal C, they equal each other, right? So we can say pi d equals 6.5 pi, right? Divide both sides by what? Doing this. And they cancel, and you get d equals 6.5. And again, they're obsessed with centimeters. Number 3 is pretty straightforward. What we got? 14 pi. 14 pi. C equals 2 pi r. 2 pi, in this case, 7. 2 times 7 is 14, so 14 pi centimeters. And for the last one? 7.75, right? So they gave us a circumference and they wanted r. So we're going to use the fact that circumference also equals 2 pi r, right? And so 2 pi r, if they both equal c, equals 15.5 pi. So 2 pi r equals 15.5 pi. Right? Let's divide both sides by what? 2 pi, get the r by itself. So they cancel, right? So 50.5 divided by 2 is 7.75 just centimeters. Okay? Hang of that? All right. Let's switch gears a little bit, bless you. Take a look at perimeters and then some circumference here. So this is kind of an odd shape here. What's going on? Scroll. Did we get a little freeze up here? All right, let's take a look at this first one. They want the perimeter. So we might have to break this thing up a little bit here. We have to add up all sides, but they didn't give it to us, right? So that's 8, right? That's 2. What's the length of this segment? That is also 2. Congruent marks, right? Okay. So let's think about this. If that's 2 and this whole thing is 11, what's the length of this segment? 9. Good, right? So this is 8. Here's 2 of the 8, right? What's the length of this segment? 6. Can we now add them all up and get perimeter? Yeah. Right? You just have to break it up and get some missing lengths in there. So it's 38 centimeters all the way around. Now over here, we have a trapezoid, don't we? Right? They give us 10, 6, and 18. We're going to have to think about this one for a minute. Is there something we can sketch into this trapezoid that will help us? Yeah. What? You mean an altitude? Is that what you mean? Yeah. Perpendicular to the base? Like maybe right here to form what kind of triangle? It might be, might not be. A right triangle, right? So what's the length of this segment? Because 18 minus 10 is 8. What's the length of this one? 6. So let's find that. Should we do the Pythagorean theorem, or do you remember a triple? It's not one of the triples. It's a 3, 4, 5 double, 6, 8, 10, isn't it? Right? So this is a 6, 8, 10, if you remember that, right? So this is 10. Or so you could do the Pythagorean theorem and get the same thing, right? But remember triple, so you add them all up. Okay. So let's take a look at this guy. So we know there's 8 of it. We need to find this half circumference, and this is a semicircle, right? Okay. So we're going to need a circumference formula.
Okay.
Yeah. Half of it, right? But first we need what part of the circle? The diameter or the radius. Okay. Oh, they gave us a diameter. So what if we get this side, this here? So if the diameter is 8, what is that circumference? 1/2 times 8 times pi, right? What's half of 8? So this length is 4 pi. What is it doing that to me? 4 pi. Now we can add it all up, can't we? Now 4 pi plus 8, they're not like terms. We can't combine them, right? It's like 4x plus 8, isn't it? So the answer is just the perimeter is just 4 pi plus 8 centimeters in exact form. Okay? All right, so down here's a few for you to try. You have to do a little bit of thinking on these guys over here, okay? Let's take a minute, okay? Set these up and find the perimeter. So you'll have to find the missing side of that triangle. Excuse me. Call this side X here, right? Well, that was weird. Something's going haywire. And we get the perimeter number 5. Perimeter is 42. What? 90. I mean, you got 41 and 9. It's gotta be bigger.
Oh, I did the side.
Well, what'd you get for this missing side? 40. X squared plus 9 squared equals 41. Remember, the hypotenuse is a thing all by itself. Squared. Right? Okay? So you get x squared plus 81. Come on. Equals, what's it? 1681. Subtract 81. X squared equals 1600. So x equals 40, right? Hey, is this another triple? Did we find a triple? Are they all integers? Well, if you can remember that one, it's another triple. Save you some work. So now we just do perimeter equals, what is it? 9 plus 40 plus 41. Came to what, 90? 90 centimeters. Okay? Number 6, this is how I don't know if you've gotten to it yet, but just the way my brain operates. I need that arc and this one, right? So I just called this A to give me something to work with, right? And then I called this one B. You don't have to do that, but that's just how I worked it out. And then I found the value of A and B, and I got some things to add together.
I thought A like the big A subtracted B. So like I thought big A including B.
Why would you? So that's why would you subtract, all right? Because I want to add that distance to that distance, and add that distance and add that for perimeter. Right? I won't be doing. So you're doing like, if you were like trying to find the area, and you'd have to do like pi r squared, get the area of this minus the area of that. We'll do that later, but you're on track for that. But right now we're adding it all together. Okay. We need this diameter here, don't we? What's this diameter? 8. So did anybody find out what A equals, or what I have here is A? So you did 1/2 pi d, right? Because it's a semicircle. So we got 4 pi for that. What about for B? 1/2 pi d, 4, yep, is 2 pi. Now we can start just adding stuff up, right? What do we get for perimeter? 6 pi plus 4, yes, right? So it's perimeter equals 4 pi plus 2 pi plus 2 plus 2, 6 pi plus 4 centimeters. Okay? There you go. Let's work on number 7. Maybe I'll just do the same thing I did before. Whatever method you use is fine as well. Call that A. Work that out and get you something to add in for perimeter. This 4.47.
I did the Pythagorean theorem that I got.
Oh,
Like
so you must have
yeah.
made a triangle somewhere.
Yeah.
So we got 4. These dots are 4, right? As Olivia says, okay? And so then we can find this as doing, so A equals, so the whole thing is 8, right? 1/2 pi d, right? Pi times 8, which equals 4 pi. Right? Now we can just start adding stuff up, right? So perimeter equals 4 pi plus 8 plus 8 plus 4. 4 pi 16 plus 20. What's going on with this board? Centimeters. Okay? All right, so we got a formula for circumference. And you now know where pi comes from. Guys, where does that number pi come from? Circumference divided by diameter in any circle. Why is that ratio the same in all circles? Because all circles are what? Similar, right? It's like any other similar figures, like even the triangles, right? It's like trig, right? The ratio of opposite over hypotenuse is the same in any pair of similar triangles. Circles have parts too, circumference and diameter. That ratio is pi. It's like the scale factor, isn't it? Kind of. All right, before we go to the Regis questions, I need to give you a quick note. Now, what I'm about to give you is, I guess I thought in algebra they don't teach this anymore. I don't think. But you do need it, okay? Has anybody ever heard of the distance formula? Did you do that in algebra?
Yeah.
We'll see. So if we're working in the coordinate plane, right? You got points in the coordinate plane, x comma y and x comma y, right? So here's the formula. Distance formula. Okay? So if I have 2 points in the coordinate plane, x1, y1, and x2, y2, just one point and the other point. There's a distance between them, right? So if I'm given this point, x1, just the first point, right, the ones, y1, and another point, x2, comma, y2 in the coordinate plane, okay? I can find the distance between them with the following formula. This is the formula you need to know. It's one of those that, well, you had to take the readings, it would not be on the reference sheet, yes.
They're like a displacement as well.
Yes, that's when you get into physics, there's a displacement, right? And that's why generally, I don't know why, so we use D here at this level. We should be actually, if you get into higher math, I believe they use a letter S for distance. Don't ask me why. The only thing I can tell you is that D in physics generally stands for displacement. Okay? But we're going to use D right now so we don't blow your little brain holes wide open, okay? So here's the formula for the distance between any 2 points in the coordinate plane, right? X1, Y1, 1 point, X2, Y2, the other point. If you draw a line between them, they have a distance. So the distance equals the square root of X2 minus X1 squared plus Y2 minus Y1 squared. Okay? You need to know that formula, okay? At some point you'll have to commit it to memory. Very common formula. If we ever get to coordinate proofs, we'll absolutely need it, okay? Okay? So that said, we have this formula now, and some of the reading questions we're about to go to will use this, okay? Maybe to find perimeter of some figure in the coordinate plane, right? So let's say you got a rectangle in the coordinate plane, and you need to know the distance on one side. That distance formula will give its length, wouldn't it? Follow me? So let's look at the Regents questions. Okay. Hey, we might have to use the distance formula here. So read that over. Make note of what the shape is. That'll be very helpful. So you're going to pick any 2 points that make a side of the square. So you like remember they put R, S, T, V in order, right? So you could pick like R and S, or S and T, or T and V, or V and R. Does that make sense? Like if I did R and S, that would be a diagonal, wouldn't it? Okay. Or I mean R and T. If I did R and T, that would be diagonal. RS is a side. Okay. So maybe I'll just get the distance of RS right there, right? RS equals square root of a bunch of stuff there. Give you a second. So parentheses, -3 minus, look at this. You probably didn't do that.
Oh, it is extra square.
See what I did there? Minus a -1. If I subtract a negative, it's the same as what? Adding. Okay? That's the x's. Plus, now let's do the y's. It'd be 1 minus 5 squared. With me? So let's simplify this. RS equals the square root of, you said that's -3 plus 1, is it not? What is -3 plus 1? -2 squared plus what? -4. See how I have parentheses around them each, right? Because I got to square the entire thing, including the negative. So RS equals the square root of what? 4 plus 16. It's S. So RS equals the square root of 20. Now you might be thinking, okay, I need to get that simplest radical 4, but take a look at their answer choices. Did they do that? No. So here's our answer, square root of 20, right? Huh? Yeah, see how they do that? They put that in there, right? So the perimeter is 4 of those because it's a square. Okay? So we get how that distance formula works now? All right, let's move on. Got another square here. Ooh, the dilation. What does scale factor apply to, guys? Any what? Any linear measurement, including what? Perimeter. There you go. So you could either apply the scale factor to the side lengths first and then add it up, or could you add up the sides and get the original perimeter and then do the scale factor with that? Yeah. Okay, well, let's do it here. What do we get for the new perimeter? So you could do each 9, right? So 9 times, wait, why am I doing 4? Oh, yeah, let's get the perimeter first. Perimeter equals 9 times 4, which equals 36, right? And then 36 times 3 is what? Huh?
Oh, yeah, I did it right. It's dilated.
Yeah. I got the perimeter first, and now I'm applying the scale factor. 108, right?
What?
Yeah, I did it right.
Or let's do the scale factor to the sides. All right, so it's 3. Let's do 3 times 9. So this is or. I told you could do it either way, right? 3 times 9 is what?
27.
27. So that's the new side length. Now let's get the perimeter. There's 4 of them. What's 4 times 27? So some of you might have done it one way or the other way. Okay? One way I dilated the side, or no, I found the perimeter, then dilated that. The second time I dilated the sides, then added them up. Number 3, you're going to want to make a sketch of. What's the shape? What do you know about rhombi? It's not a square.
Opposite sides are parallel.
Well, that's because it's a parallelogram. When we're going around this, we got more criteria.
That's 4
All 4 sides are congruent. So I'd make a sketch right out of the gate. Yep, that's smart. Rhombus. It's not necessarily square, right? V-E-N-U. V-E-N-U. V-N, intersected. So we got ourselves some diagonals in here, right? Oh, and now, what do you remember about the diagonals of a rhombus, children? Yeah. If I said to children because it's a parallelogram, but when it becomes a rhombus or what, Thomas, you said? Was it Thomas? It was you. Oh, God, I thought it was Thomas.
I'll take it.
The perpendicular in a rhombus, right? Which means we formed what inside there? Right triangles that you know how to work with, right?
Oh, I did that. Be
Careful. So let's do it. So VN is 12. That means that this is 6 and 6, right? The other one's 16, so it's 8 and 8. What's this?
That's 2 points.
So it's a 6, 8, 10. Or you could do the Pythagorean theorem, right? So x equals 10. So we circled 10 in our choices.
Yep, I did.
False. See what they do every time, right? Perimeter is 4 times 10, which is 40. Okay? You see how we don't forget the stuff we learned? Quadrilaterals, right triangles, it all comes in, right? That's why I couldn't skip anything to shorten this course at all, because if I did, you know, what are you going to do? All right, hey, looks like I got another rhombus. Yeah, it's fine. You don't like them? So you can pick any 2 points that form a side. Don't pick 2 points that form the diagonal, right? So basically any 2 consecutive points that they list there. Got it? Use ST. So ST equals the square root of a big mess. Yeah, number 1. Right? We use the distance formula. It's deja vu all over again. Redundant. I'll just work on it while you're doing it. So we got, let's see. Wait a minute, why do I have 2 plus 1 here, guys? I thought it was x2 minus x1. Oh, it's minus a negative. I'm shortcutting a little bit there. You all catch that? Just know that anytime you subtract a negative, it's the same as adding. Okay? Anybody get the length of ST yet? Just say it. Square root of 10. What's 3 squared is 9, plus 1 squared is 1, right? So ST equals the square root of 10. And again, that's one of the answer choices, but we're looking for perimeter. So what's a perimeter? 4 square roots of 10. There you go. Moving along. That's another rhombus. They love rhombi. They love rhombi. And they even gave us a sketch. But this one's got a little twist to it. Read it over. They gave us the perimeter. 68. The length of IE. They want IE. So the perimeter is 68 and TG is 16, and this is 8 and 8, right? 8 and 8. And we know it's a rhombus, so they're perpendicular, right triangle. Okay? So we know we're going to work with a right triangle, so I'll call that little segment X. But how do we get this hypotenuse?
68.
Yes, the perimeter is all 4 sides. So 68 divided by 4 gives you what? 17.
Agreed, the arrow.
It's a triple. What triple is it?
8,
8, 15, 17, right? So that X is 15. But be careful. See? They want IE. So IE equals 2 times 15, because diagonals bisect each other, 30. All right? 2 more. This one you're going to have to remember something we talked about a few times a while back. Scale factor is 3. So our new perimeter prime, would be what? Right? 12 times 3, which is what? 36. Okay, so that narrows it down to 2 or 3. But now let's go to the area. What's the area? 6. Area prime, is it going to be 6 times 3? Aha! Remember what you do to scale factor to apply it to area. What do? K squared is what? 9. So the new area is 6 times what? 9, which is what? 54. Okay? If you go into area, you have to square the scale factor, because area isn't square units, right? Okay, one more. Somebody got that? Yeah, okay. So, we need to get the circumference of these necklaces, right? To figure out how many of them can be made with 1,000 centimeters, right? You with me? If we know the circumference of the necklace, we can divide 1,000 by that circumference, right? Okay. So, circumference is what formula? 2 pi r. They gave us a radius of 10. Well, then you have to change it 10 to 20, but that's fine. Okay? So, our circumference, 2 pi r. Circumference will be 2 pi times 10, which equals 20 pi, right? So now we're going to do 1,000 divided by each necklace's circumference, right? So if we do 1,000 divided by 20 pi, I want everyone to put that in your calculator right now. Tell me what you get. What did you get when you put that in your calculator? Whatever that. Yeah, someone else. Put that in your calculator. Can't wait. You just pipe down. That's what I wanted to hear. No, I meant 1,000 divided by 20 pi, guys. You got 157, did you?
Yeah.
Oh, I put it on my calculator.
You know why? You want to know why? Because here's what you put in your calculator. 1,000 divided by 20 times pi. So what you did is not what I wrote here. You did 1,000 divided by 20, and then took that result and multiplied it by pi. What should you have included in your calculator button pushing? Yeah, around what? Around that. Now try it. Everyone try it now. Do 1,000 divided by parentheses 2 pi, close
I
parentheses.
found out.
Use it.
I got the same facts.
I got the same thing. Oh, wait, why?
I did it 1,000.
So that equals 15.9. So we can make 16 necklaces, right?
No.
Not exact. So this is you're used to rounding up to 16, right? We cannot make the 16th necklace. Okay, this is important. Cannot make the 16th necklace. Okay, so we can get as many as 15 necklaces out of 1,000 centimeters of wire. Okay,
How much money is
I have no idea.